I would like to invite Dr. Norazlina. Okay, so thank you for sharing your presentation today. Please begin your presentation.
Okay, thank you to Chairperson Miss Alisa, is it the Chairperson? And then our moderator, Dr.
Yuriana,
Yuriana. Hi, Doctor. Nice to meet you.
nice to meet you, Doctor.
Okay. First, I want to congratulate the students of this is students of Bina Putri, is it? Seminars. Congratulations for this seminar. Good morning, selamat pagi, Assalamualaikum dan salam sejahtera semua. Uh, uh, to Mr. Dr. Thank you, Mr. Dr. Insigne Oki Sediayanto, Mr. Richard Lord Disha, Mr. Andrew, and Maria Putri, who is always WhatsApp me. Okay. My topic today is about green infrastructure and resilient. Do I need to share my screen or you share the screen?
I think you can directly share the
Okay, I try.
presentation. Yeah.
Hold on, still sharing. Can you see my presentation slide?
Yes, clearly. Yes,
Boleh tengok my presentation slide?
yes, we can see it.
Hello? Can you hear
Yes,
me?
Dr. Norazlina. Hello?
Okay, I am sharing the presentation slide. Can you see my presentation slide?
Yes, we can see your slides.
Yes, Doctor, we can see.
Doctor, can you unmute? Sorry, Dr. Norazlina, we cannot hear you.
Dr. Yuri, can you
Ah.
help me share the slide? Because I think it's lagging when I share the slide.
Yeah, we can see your slides. Can you hear my voice?
Yeah, but then when I share the slide, it's lagging. Can you share my slide for me?
We can see your slides.
Okay. Okay, you can see the slide, is it?
Yes.
Okay.
Can you hear mine?
Yeah, I
Yes,
can hear.
doctor. Yes, doctor. We can see your slide.
Okay. Thank you. Okay. Talking about green infrastructure, I want you to look around you. We are now in a flooding season. The flood is everywhere. You, as the future of engineers, are facing of reality of our predecessors. A more intense flood. Kalau buka sosmed, if you open up TikTok, social account, Facebook, and etc., you can see rain everywhere. There is increase in runoff. There is land urbanization, land development everywhere. With then, and another thing is urbanization and flood issue. Okay. Then you can see that from the sinking ground in Jakarta to the flash floods in KL, the challenges of the future engineer is very massive. Okay. Okay, next. Flood is due to the unplanned urbanization. You can see there is overdevelopment, there is deforestation, there is climate change, there is overflow of drainage due to high intensity, continuous rainfall, extraordinary heavy
Oh,
and prolonged rainfall. Then you can see the failure of hydraulic conveyance due to the overflowing river and our drainage system. This picture is Masjid Jame at KL during March 2022. Flood, historical flood can be seen since 1936 to 2014. Flood, the punya graph is rising. Rising. We have monsoon flood in this November to March. There is also flash flood. There is also coastal flood. Okay. And kalau monsoon flood, we can see it during this time, November to March. Then we move to climate change. Okay, we are now talking about the problems that we face nowadays. There is urbanization, there is floods everywhere, there is climate change. What is climate change? Climate change is now real and it is significant. You can see the deforestation, and you can see the pollution due to urbanization. Okay, climate change can be due to a sustainable development, deforestation, lack of waste management. There is also carbon emission. There is global warming due to greenhouse effects, panas yang melampau, under warmer conditions, Earth turns warmer, Antarctica melts, sea level rise as a result of increasing water volumes, and due to climate change, it is harder to predict the weather with high accuracy level. And according to the study by the Sixth Assessment Report in 2021, they estimate that the increase in annual rainfall in the world by plus 291 millimeter, 12% in 2050. Meaning that kalau Malaysia, our rainfall annually is about close to 3 to 4,000. I think it is similar with our neighbor, Indonesia. The 4,000 will be plus 290 mm. And in 2100, it increased to plus 567. So it will be close to 5,000 millimeter rainfall annually. And our monthly rainfall, kalau musim hujan like this, December and January is about 3 to 400. Imagine that we are receiving rainfall about 3 to 400 during December and January, and this is causing the overflowing of river, and then causing the flash flood, causing flood everywhere. And when it flood, kita akan menyebabkan when it is flood, our system, the residential need to pindah ke mana-mana, and of course it will be lost in our economy. Okay, then still talking about climate change in Malaysia, a small change of temperature can bring a huge disaster, okay, such as an unpredictable weather and sea level rises. When talking about sea level rises, then we will talk about overflowing of the river. Okay, the southern part experience the most temperature exchange up to say 0.6 degrees Celsius in 20 years. And if this pace continue, the changes to Malaysia will be 1.1 degree Celsius from 0.6. And even though we are at Malaysia or at Indonesia, no one was excluded from this climate change. Okay. Then talking about urbanization and land development, this is in 2005, and now we can see concrete grey infrastructure is everywhere. Okay, if it is urbanization, meaning that the percentage of population in urban centers will be up. Okay, and this is in Indonesia, urban will be so many rather than rural part. Okay, for the city challenges, today is about 3.5 billion people. Half of humanity live in cities. Okay, and there is the city will be more cramped. Okay, then in 2030, 60% of the global population will live in cities, and in 2015, 80% of the mega cities is located in river deltas that make it hot. Okay, overflowing of the river, of course, definitely will flood all that urbanized cities. Other than climate change, other than urbanization, I would like you to see what happened to our drainage. Drainage is our hydraulics conveyance. Hydraulics conveyance system need to be maintained. We design the drain so that it can catch the runoff, it can catch the rainfall. But if a system that we are designed to catch the rainfall cannot catch, and it's failed due to our behavior, we throw the rubbish here and there, then the system will clog, will block edge the drain, will sedimented, will be sealed due to the trash, due to the debris, litter, rubbish, and polluted our system. Okay, this is happen when we didn't do any awareness, when we throw, kita buang saja sebarang, we didn't took our responsibility to our Mother Earth. Okay. Talking about extraordinary rainfall, it's linked together with the climate change. You can see now, dulu mana ada hujan yang sangat banyak. Okay, now we have to face this extraordinary rainfall season. Okay, selalunya we as engineers, we design our drain according to 10 years, 1 in 10 years average recurrence intervals, 1 in 20 years average recurrent intervals. But when it is rain for 1 in 50 years, 1 in 100 years, then finish. Then our drainage system, our hydraulics conveyance will be full of water, overflow, make it flood everywhere. So when you are the engineer, need to design a rainfall, you have to know your rainfall. What is mean by once in 10 years, 1 in 50 years, and once in 100 years rainfall. Okay, how we measure the rainfall? How we measure the rainfall? There are two types of measurement for the rainfall. Either we want to measure it by depth, using precipitation, or we want to measure it using intensity in millimeter per hour. Maksud dia dalam sejam, berapa jumlah hujan yang kita receive in millimeter in hour. And how depth is depth? Okay, how depth? Let's say it is talking about depth in millimeter. What is that mean? How depth is according to watershed or area that the rainfall covered. Okay, say that we have that station of the rain gauge is covering about 1 acre. Then the 1 acre, the depth of rainfall, let's say 1 in 5 years is about 40 millimeter. 40 millimeter means from the zero bottom of the platform level to 50 mm. That is the depth. How we measure design precipitation? Why? Because we need to know the severity of rainfall and what duration it can cause flood, so that our as engineer, you as the future engineer can design any stormwater infrastructure, any green infrastructure to untuk catch, untuk tangkap, untuk store the amount of water. Okay, there is the intensity. Kalau Malaysia, the categorization of rainfall intensity can be in terms of intensity and degree. Okay, intensity is in millimeter per hour. If it is less than 0.65, it is low. If it is more than 5 millimeter per hour, it's already considered critical degree of rainfall. Okay. In terms of storm category, it can be in terms of light, moderate, heavy, and very heavy. And in our Malaysia, we already consider more than 60 as very heavy. Apalagi kalau we receive rainfall about 100 millimeter, then it definitely will be flood. And convective rain more than 60 millimeter in 2 to 4 hours duration may cause flash flood within the 2 to only 60 millimeter. Panjang pembaris double, pembaris pendek 30 plus 30, then with that amount of rainfall can definitely cause flash flood. Therefore, as an engineer designing a hydraulics engineer, in Malaysia, we will follow manual saliran mesra alam or urban stormwater management manual in dealing with this amount of runoff or rainfall. We will choose either it is designing for minor system or we want it to be major system. This is the type where we want to develop the area, such as if it is residential, so bungalow and link house, so we will design it for 5 years. If it is drain, then we design it for 1 in 5 years rainfall sahaja. And if it is university, commercial, industry, school, and etc., it will be designed 1 in 10 years average recurrent interval. The major system will be like smart tunnel, a dam, and etc. If the major system, the hydraulics conveyance that is designed will be 1 in 100 years rainfall. Okay. Still talking about rainfall, because this is I think we are civil engineer students. Talking about intensity, duration, frequency curves. Rainfall intensity, duration, frequency, IDF curves is a graphical representation of the amount of water that falls within a given period of time in that catchment areas. And it is used to aid the engineers to design urban drainage works. Okay, kami kalau di Universiti Malaysia Sarawak, we learn this one during our third year hydrology class, designing an urban drainage networks. Then the establishment of such relationship was done as early as 932 according to Charles Vente. Charles Vente is the father of hydrology. IDF relationships is a mathematical relationship between the I, the D, and the return period T, or equivalently the annual frequency of exceedance F, typically referred to as frequency only. Okay, frequency is talking about 1 in 2 years, 1 in 5 years, 10 years, and etc. Indeed, the IDF curves allow for the estimation of the return period of an observed rainfall event, or conversely, the rainfall amount corresponding to a given return period of different times. Okay, two common frequency analysis techniques to come up with this IDF curve is using Gumbel distribution and LPT distribution. What is IDF curve? This is IDF curve. Intensity, duration, frequency curves. Selalunya when we design drainage system or any urban infrastructure to capture rainfall, we will talk about how much water, how much rainfall that we want to store inside that drain. Okay, say we will find out that the intensity. This one is talking about duration frequency curve. For this one is this formula I equal to lambda tk over d plus theta n, and k lambda theta is fitting constant, nilai yang diberi, value yang diberi following the Gumbel and LPT. And for Sarawak and Sabah and for Malaysia, we can obtain this value from MASMA, and from Sarawak and Sabah it is HP26. It is available online. And T is talking about the years, the frequency, 2, 5, 10, 20, 50 and 100 years return period. D is about which duration you want to design that rainfall, in 20 minutes or etc. It can be lag interval times of 5, 10, 20 until 24 hours, depend to you. But in urban drainage system, D here is the time taken from the longest, the root of, let's say your rainfall falling to the ground, the first root, the zero root, it took to go to the most main outlet. The minimum of D duration is about 5 minutes for Malaysia condition. Even though sebenarnya kalau hujan turun, if the rain falling, then it will not take about 5 minutes. Turun saja, terus masuk drain. Within this drain is the outlet, the main outlet. We are talking about one catchment, and the main outlet at the end. And it will take, for Malaysia, our minimum time is 5 minutes, and for urban condition it will take about 15 to 20 minutes to reach the drain system. Okay, sorry, I hope you are not boring with me. Okay, then I would like to talk about hydraulic system. Okay, tadi I talk about the rainfall system itself. Let's move to the hydraulic system. Okay, the rainfall is about hydrology system. Hydrology. So if we talk about rainfall, we are talking about hydrology, the amount of rainfall that we need to manage. Now we talk about hydraulic system. Hydraulic system ialah the system that can store, that can catch, that can receive the rainfall, and with that hydraulic system we can control the flood. Okay, our hydraulic system can be natural hydraulic system, can be man-made such as stream. Stream, of course, it's natural. River and drainage as rainfall runoff conveyance. It can be in this stream, river and drainage system. We can talk about watershed concepts. Where is the upstream? Where is our downstream part? Of course, the upstream is kawasan bermulanya the stream and goes down to the downstream, that is river mouth. Okay, kawasan sungai sehingga kita jumpa sea. Okay, then talking about hydrology and hydraulics of this system, and drainage or hydraulics conveyance system design. Sources of stream flow can be watershed or catchment consisted of river and stream. Large watershed are made up from smaller watershed. Of course, selalunya our upstream part is the mountainous area, starting from very straight stream, very river that is very shallow, then goes down to middle part that is very looks like a snake, concave, bend, and etc. until it reach the sea. Okay, large watershed are made up from smaller watershed, consists of land area that sheds water to outlet during rainstorm, and rainfall contribute water to the outlet point. There is one. Kemudian there is also a retention. Retention is like a pond. Is storage held for a long period of time and depleted by evaporation. That is retention. We can talk also about detention. The comparison between retention and detention. Retention is a pond. The water is stagnant in that area, but detention, it is a short-term storage depleted by flow away from the storage location. It store water only in short time. It can be permeable pavement, can be padang bola sepak, can be anything that can help store water. And then overland flow. Okay, let's us move into the old paradigm. This is urbanized floodplain. Before, we can see that there is forest everywhere, green and etc. And then there is residential everywhere, and you can see that the flood, the drain, the earth drain, due to rainfall there. Traditional practice. This is, I'm talking about Malaysia. Before this, our traditional practice, our old paradigm on managing rainfall or managing stormwater runoff is rapid disposal method or conveyance oriented approach. What does that mean? When it is rainfall will become runoff. Then the runoff will dispose as fast as possible to the hydraulics conveyance, to the drainage system, and to the stream. That is traditional practice. Hujan turun, terus jadi rainfall, terus jadi runoff, and it goes to the hydraulics system, terus goes to the drainage system, and that drainage system will flow it to the nearest stream or the nearest river. And during our traditional practice, what we do, how we manage stormwater, we maximize the conveyance capacity. We are talking about concrete drain only, drain sahaja. And if it is a concrete drain, if the concrete drain cannot store the amount of rainfall, we will widen it, we will deepen it, we will strengthening it, and we will lining it. That is the traditional practice in maximizing the conveyance capacity. Design approach is disposal. Dispose as soon as possible. It is open loop system, and we want the runoff as fast as possible goes to the lakes and goes to the watershed or goes to the water bodies. And we want it as fast as possible. And the system is combined with the stormwater sewer. The old paradigm, this is what happened during the old paradigm. Hujan turun, the rainfall goes as fast as possible to the downstream. This is upstream, and the downstream and go to the river. And what happened? What happened? Upstream selamat. Upstream okay, but the downstream part, the floodplain area, will be river overflowing. Okay, heavier rainfall in polluted, little vegetation to absorb moisture, minimal infiltration of water, no deep percolation, and etc. This is what happened during post-development. Runoff, let's say we have 100% of rainfall. 100% of rainfall turun ke bumi, 35% will become ET, evapotranspiration. 50% will become runoff, but only 50% infiltrate, meresap masuk ke ground. Only 50% goes to the ground. This is the difference between pre and post development. Okay, jarang kita dengar rural area banjir, but it's common to have urban area to have flash flood everywhere. Why? Because the grey infrastructure, concrete is everywhere. Runoff become 50%. Runoff is air hujan yang tidak meresap masuk ke dalam tanah. Okay. Here, when it is green area, the runoff become only 5%. And 40% become a groundwater, infiltrate to the ground. And this is happen during Q post, selepas development and Q pre. Post development peak flow and pre-development peak flow. When it is natural ground, the evapor is about 40% rather than 30%. The 10% become runoff, 55% is runoff for urban development, 5% deep infiltration, 10% shallow. So the groundwater is already very shallow. Rather than here, this part is 25% deep, it goes down to the groundwater. And 35% become shallow infiltration. And Q post is more Q larger rather than Q pre-development. Okay. This is what happened due to the old paradigm. Concrete is everywhere. Hard structure, grey infrastructure, development is everywhere. And what happened if the development is everywhere? No runoff is there, no infiltration happen, peak flow happen, and flash flood can be seen. Okay. I'm talking about Malaysian street. You can see this is very hard concrete. No place for rainfall to infiltrate the ground. And we are talking about flood here, where we want to store the water from the rainfall. Okay, due to that, there is a need for an approach of stormwater management, green infrastructure. What is storm? Storm is hujan, pengurusan hujan. stormwater management. Stormwater management is talking about how we can balance the environment, balance the economics, balance the social. These three work-life balance, environment, economic and social balancings. And through this, we need to apply green infrastructure. Okay. Talking about green infrastructure in the world, we have low impact development. We have, this is a USA term. We have sustainable drainage system, SUDS, UK. Water sensitive urban design, this is Australia terms. We have active, beautiful, clean waters design guideline, PUB is Singapore. We have sponge city. Sponge city is where they design the system to absorb water like a sponge rather than hard concrete, rather than the rock. The rock will be push water, but with the sponge, they will infiltrate the water. Okay. This is still talking about the term that is used. Okay, we are moving into this green infrastructure, following similar with the United States of LID, Australia WSUD, Britain UK SUDS, New Zealand is talking about LIUDD, Malaysia is about manual saliran mesra alam, and in Sarawak, in our state itself, we have the manual, the standard codes and guidelines to manage our stormwater. We call it as Sarawak Urban Stormwater Management, the adaptation of MASMA. But with this system, we put a guideline, a list of code of standard of requirements that any developer, any contractor, any consultant need to follow, such as when there is any development, 30% of the area must be green area. And then with that 30% area, 10% should be, need to be, must have system facility. Okay. Now we move to what is system facility. Okay, this is talking about Sarawak Urban Stormwater Management and Manual Saluran Mesra Alam. Okay. Stormwater management is talking about quantity control, quality control, erosion and sediment control to ensure that no sedimentation happen, the operation and maintenance of this system, and the aesthetic value. Okay, how to make it beautiful with this green nature based solution rather than grey infrastructure, only concrete everywhere. This is example of urban stormwater management technologies. We have constructed wetlands. It can be permeable pavement. It can be bioretention system, vegetated swale, or rainwater harvesting system under the building to help capture this rainfall that become runoff. Okay. This is example of a rainwater harvest, rain garden system, permeable pavement, rainwater, underground rainwater harvesting, bioretention, rain garden, and etc. Okay. Talking about quantity control. Quantity is how we can capture the rainfall according to MASMA, Stormwater Management Manual, and according to system. Okay. As I mentioned before, 30% of that development yang kita nak develop, if you are engineer wanted to develop a site, wanted to design a search catchment area, 30% must be a green area. From that 30%, 10% is recommended for any green infrastructure facilities. It can be on-site detention pond, it can be dry pond, it can be wet pond. Okay. On-site detention pond is a very big drainage system can be located at below ground or can be above ground tank. Okay, they call it as on-site detention pond. And these types of green infrastructure is recommended for less than 5 hectare, development area. While for dry pond, this is the dry pond system. You can make it nice, back to nature, tree planting here and there, and make it as a recreation place for people to jog and walking everywhere. And this system is recommended for 5 hectare to 10 hectare development area. And for wet pond, it have a permanent pool level. Above this permanent pool level will be a spillway, and the design flood level will be higher. And the suitability will be following the topography, will be following the geology, the internal, how big your site is, subcatchment, and connections to the main drain. But these three, this system is a must for development, for consultation, for contractor in Malaysia to do any development project since 2018. Rather than rapid disposal system, you have to manage your own runoff in your own catchment area, and we name it as control at source approach. This control at source approach, you have to manage your runoff, and this runoff will be slowly goes to the main drain.
Excuse me, Dr. Norazlina. You have 3 more minutes.
3 more minutes, okay.
So
I want to show more. This is about detention pond, how we design that detention pond. Example of the detention tanks that is located below. Another detention tank. This is detention tank system that is already there. Dry pond at Sarawak. Another dry pond, how the system works. We need to have a cage, a fence, a gate to ensure the safety. The design of it, how it's look like, the signage we need to this has for the safety procedure. And another one is wet pond for recreational purposes. When we talk about back to nature, we can have it as recreational also, and the system have multi-purpose to capture the rain and to be as recreational park. Another retention pond, rainwater harvesting, talking about permeable pavement rather than using parking that is solid concrete. We can use permeable pavement, a very beautiful looking into the PICP, permeable interlocking concrete pavement. Another types, underground permeable pavement. This is at UNIMAS campus. This is my PhD stone path. As underground pavement, permeable pavement can be used as road and also detention pond. MOVA, another detention pond system by UNIMAS researcher. This is swells. Swell is earth drain, but then this earth drain, we have another system here. It looks nice. Swell, bioengineered drain, looking also like a drain as well. Stormwater tree trench at the roadside of the road. that can help to infiltrate the water. Another stormwater tree trench, green streets, a rain garden. As I mentioned about back to nature, making it beautiful with greens area rather than grey infrastructure. Another rain garden, very nice, very lovely. This is a very big infrastructure, underground flood storage and transfer tunnel. We can see this one in Japan. And then another one, our smart tunnel. This is one longest tunnel. It receives CNN top 10 world's greatest tunnel. It is a multi-function tunnel, can be storage of stormwater runoff and can be highway. This is our Tun Mahathir initiatives. How it's work. You can see the link to smart tunnel using this YouTube. Another on smart tunnels. And I want to talk about community awareness and flood alert, as this is a flooding monsoon season. You have to have disaster kit, prepare the disaster kit, come and have a plan, gather your important documents, say you are living in a flood prone area, stay alert and updated, save the important numbers such as bomba, fire, and rescue, GPAM and police, preparing all these things for a disaster kit. And your generation has for a calculations, your generation, the engineer, you as a new generation today, Gen Z or Gen Alpha, has the knowledge, the technology, and the urgent need to redesign our world. The choice is on you, and it is simple. As the future engineer, and maybe some will be a policy maker, do we continue to build a brittle single proposed grey system that is failed spectacularly, or do you want to design a beautiful multifunctional green system that adapt, that evolve and sustain our community? Green infrastructure is not a trend, it is a professional responsibility of you as a future engineers. I urge you to study it, to advocate for it and your careers, and build your careers around it. Thank you. Terima kasih. Congratulations everyone. And I'd be happy to take your question. Thank you. Thank you, and sorry to take so many times.
Thank you so much, Dr. Norazlina, for the comprehensive presentation.